Okay guys, so in this video we are going to talk about speed, velocity and acceleration. Speed, velocity and acceleration, all three of them are physical quantities. Speed is a scalar, whereas velocity and acceleration are both vectors. You can remember them from their first letter. Speed starts from S, so remember it to be a scalar, whereas S stands for a scalar, as velocity v stands for a vector. This is a technique to remember them. Well, it's quite easy though, and you guys know what scalar and vector is, as I've discussed them in previous videos. Scalar is any physical quantity that does not have a specific direction, whereas a vector has a specific direction as well as a magnitude and a unit. Scalar only has a magnitude and a unit. Okay, let's look at the definitions. These are important definitions because they are repeatedly asked in the exam for at least 1 to 2 marks. Okay, speed by definition is the rate of change of distance. Rate of change of distance means basically change in distance with respect to time is equal to speed. Mathematically, this is one way of writing it. It can also be written as speed is equal to distance covered, which is basically the change in distance divided by the time taken in covering that distance, so divided by the time. Okay, the speeds are of two types: average speed and instantaneous speed. Average speed is the speed that is calculated for the entire journey, whereas instantaneous speed is the speed that is calculated for an instant during that journey. For example, if a car is moving from a point A to a point B and then it moves to a point C, okay, moving from A to B, the time taken is let's say 10 seconds. From B to C it takes 10 more seconds. The distance from A to B is, let's say, 10 meter, and the distance from B to C is also 10 meter. Okay, so if you are asked to find the average speed by definition, by basically mathematically is the total distance divided by the total time. It is very easy to find the average speed. Just plug in the values into this formula and you'll get the answers. So basically, in this case, the total distance becomes 20, 10 plus 10, and the total time becomes also 20. So the average speed becomes 1 meters per second. Whereas the instantaneous speed can not be calculated directly from a formula, but rather it is calculated from the distance time graph. The gradient or the slope of the distance time graph represents the speed, right? So if we need to find the instantaneous speed, for example, let's say we need to find the speed at time is equal to 5 seconds, or let's say we need to find the speed at time is equal to 15 seconds, etc. We can just calculate the gradient of the distance time graph that we are going to sketch. I'm not drawing the distance time graph in this video, but the distance time graph that we are going to sketch, we'll just calculate the slope at time is equal to 5 seconds, and then we'll get the slope of that distance time graph will equal the instantaneous speed. But greater questions are asked on average speed in the past year papers. Okay, this is an important point. It has been asked in the past year papers, so better look at it carefully. When a body moves with constant speed means the speed is not changing, it's uniform. So the average speed will equal the instantaneous speed as the speed remains the same. So if the speed remains the same, the average speed and the instantaneous speed, they become equal. So this is all about speed. Speed is a scalar and the mathematical representation and its definition, etc. We are going to do the numericals later. Okay, now let's move towards velocity. Velocity, as I discussed earlier, is a vector. Velocity by definition is the rate of change of displacement. This definition is important and has been repeatedly asked in the exams, so better learn it for one mark usually, but might come for 2 marks, so 1 to 2 marks. Okay, it is the rate of change of displacement. Mathematically can be represented as uh, dx dt is basically x represents displacement over here, so difference in displacement upon difference in time. So change in displacement with respect to time is velocity, which is a vector again. It can also be written as displacement upon time. Similarly, similar to the average speed that we've just discussed up there, over here average speed was total distance upon total time. Average velocity is the total displacement upon total time. Okay, this is important. I've seen some questions being asked on this part as well. So remember this formula. We also have instantaneous velocity. Just like instantaneous speed, instantaneous velocity is also equal to the gradient of displacement time graph. Okay, it's equal to the gradient of displacement time graph. Average velocity and instantaneous velocity, when they become equal, we say that the object is moving with constant velocity. Just like in the earlier case that we did up there, when the instantaneous speed and average speed they become equal, the body is said to be moving with constant speed. Over here, when the average velocity and instantaneous velocity become equal, the body is moving with a constant velocity. Such a motion is known as uniform motion. And in this case, since the velocity isn't changing, we say that the acceleration is zero. But we'll talk about acceleration after velocity in a bit detail. Now, velocity is a vector, so it can have both positive and negative signs. Okay, so speed was a scalar, it could only be positive, but the velocity is a vector and can have both positive and negative signs. So for example, if I have some ball, I throw it with a speed of, let's say, 10 meters per second with a velocity of plus 10 meters per second, taking the right side as the positive direction. It hits a wall, and after hitting the wall, it rebounds with a speed of, let's say, 8 meters per second. The speed is 8 meters per second. The speed is positive. Speed does not concern the sign, but the velocity over here of this ball is gonna become minus 8 meters per second because this velocity is opposite to the initial velocity with which the ball was thrown. Okay, this is our wall. Okay, now after velocity, okay, since velocity is a vector, to add velocities, vector addition rules apply. We are going to use the head to tail method to add velocities and get resultant.